Okay, let's move on to question number 2. I've drawn out those little discs, but apart from that, I haven't started anything else. Let's read through the question. It says we've got two particles, P and Q. So P and Q. P has a mass Km, Q has a mass M. These two are moving towards each other, so I haven't got any choice but to put that one as 3U and to put that one as U on my diagram. This is the before diagram, and then afterwards, what have we got going on? Well, we've still got P, it's still the same mass. We've still got Q, and that's still the same mass. What happens is it says, as a result of the collision, the direction of motion of each particle is reversed and halved. Right, so I don't have any choices with this diagram situation set up at all. I've got to have U over 2 and 3U over 2, and in those directions. Okay, if I'm looking at this then quickly before I get started with it, I can see I've got a mass, a speed, a mass, a speed, a mass, a speed, a mass, a speed. I've got everything. So if I've got everything, I can just jump straight into the conservation of linear momentum formula, and K should just drop out. It should be the only thing that I don't know when we're going through and doing it. So when I'm doing these, I write using CLM. I'm trying to save myself a little bit of time, but what I do is I actually write that formula down each time, more than anything, because it's helping to secure that in my mind in terms of remembering formulae. So I'll just finish writing it down. I've got to speak and write at the same time. Yeah, the initial momentum is equal to the final momentum there. So I've got those ones, and then just plug in everything that we know. So we've got Km times 3U plus M times minus U. I'm taking that direction as being positive in terms of my, you don't have to, but that's the way that I'm going to go with it. You don't even need to put that positive on there. I would telling you, but if it was part of my answer scheme, I wouldn't necessarily have that, I don't think. So I've got that's equal to Km times minus 3U over 2 plus M times U over 2. Always a quick check to make sure that I've got these two, which are going in this direction, that I've got them all as the positive or negative in the right way. Just rearrange it to get K now. So we've got 3 KMU minus MU equals minus 3 KMU over 2 plus MU over 2. The M's can cancel. And then just rearranging all that, again, just like with the last one, I'm not going to spend ages doing that for you, otherwise these videos will be too long. K works out to be equal to a third. I would hope that doesn't cause you any problems from that first bit there. And then the second bit says, find in terms of M and U the magnitude of the impulse exerted on Q in the collision. So when I'm doing an impulse question, I can either think about taking that situation for the Km mass, or I can take that situation for the M mass. It doesn't matter which one you do, because the impulse is the same either way, and it doesn't matter which way you do, because if I get minus 3mu over 2 rather than 3mu over 2, it's asking me for the magnitude of the impulse. So if I'm doing part B here, I'm doing part B, I'm going to settle for taking that one. So I is equal to M V minus U. So in this case, this is M, and whichever way I take as positive, if I take that way as positive, then I'm going to get a half U minus U there. Okay, so either way round, I'll still get that I'm adding those together, and in fact, that comes to 3 over 2 mu. You did not need to do it in that way. You could have chosen the other object. You could have chosen this object and taken that way as positive. As long as everything then works out correctly relative to each other, it will still work. Hopefully that makes sense for question number 2.